Hi, Miss Barber here. This section is titled The Precise Definition of the Limit. Suppose f is defined on an interval including a, except possibly at a. Our informal definition of a limit is that L is the limit of f as x approaches a if f of x is as close to L as we please, provided that x is close enough to a. We now make this precise by saying just what we mean by as close to L as we please and close enough to a. The formal definition. Let f be a function defined on an open interval, including a is an element of R, except possibly at a. We say that the number L is the limit of f as x approaches a, and write limit of f of x equals L if and only if for every epsilon greater than 0 there is a delta greater than 0, so that the absolute value of x minus a is strictly greater than 0 and less than delta, implies that the absolute value of f of x minus L is strictly less than epsilon. Just a quick lesson on Greek letters. This thing that looks like a backwards 3 is epsilon. That thing that looks like a fancy D is the lowercase delta, and looks like a lowercase c with a bar through the middle. We use it to mean element of. What does the definition circled means? It means if we can put a little radius around A, we should be able to get to some specific value that has an upper bound and a lower bound closing in on the value of L. Let's see what this looks like. Example, prove that the limit as x approaches 4 of 8x plus 3 equals 35 using the definition of the limit. In order to write a nice proof, we have to first do some preliminary work, taking into consideration the statement of the definition. Now let's note, we are given that the epsilon is positive, and what we need is to find some delta that satisfies the criteria. We need to find out how they relate. So how do we do that? The 8x plus 3 is the f of x. 35 is the limit. So we might write the absolute value of f of x minus L and see how that relates to, now we're looking at the limit as x approaches 4, so the absolute value of x minus 4. Let's put in the actual values for f of x. So f of x, we'll put in 8x plus 3. The limit that it approaches is going to be 5. Let's do some arithmetic. That would be equal to 8x, and 3 minus 35 is 32. We'll continue with some algebra. 8 is common to both 8x and 32. 8 is a positive number, so we can just write that outside of the absolute value, and we still have x minus 4 remaining. The x minus 4, we see how it relates. That is, we see, or we have figured out, that the f of x, that's 8x plus 3, minus 35 is 8 times the x minus 4. So, if we write it using delta and epsilon notation, the absolute value of 8x plus 3 minus 35 is less than epsilon if we let delta equal, remember, x minus 4 is 8 times, so we'll take the epsilon and divide it by 8. That's the information we do. So in the actual proof, start out by writing the proof and write given epsilon greater than 0. We let delta be 1/8 of epsilon. Then if the x minus 4's absolute value is between 0 and delta, it follows that the absolute value of the quantity 8x plus 3 minus 35 is 8 times the absolute value of x minus 4, which we got to in the preliminary work, and that's going to be less than 8 times the delta, which we assigned as epsilon over 8, which equals epsilon as we needed. Now I'm going to use 3 dots that look like corners of a equilateral triangle. That notation means therefore. So the 3 dots mean therefore. We say that by the definition of the limit, we have shown that the limit as x approaches 4 of 8x plus 3 is 35.